Okay, make sure you have a calculator too. So this is review for summative 7. I don't know that the sections are on the quiz in the same order that they're on here. I can't remember. But yes, someone asked me to do number 1. It is messy, and I don't think it's this messy on the quiz, honestly. When you add, you need a common denominator, and you need to keep the common denominator. So 4 over a plus 5 will need to multiply by an a plus 2 over an a plus 2. The minus is part of what makes this problem really ugly, and the fact that it has a binomial in the numerator, because we're going to have to multiply, whoops, that one had a 2. We're going to have to multiply by an a plus 5 over an a plus 5. Now, I don't want to spend a lot of extra time on this, so I'm going to go kind of quickly here. You would need to FOIL all that together. You would end up with a 2a squared plus 10a minus 1a minus 5. So you would have, and then you would distribute over here as well. So you'd have a 4a plus 8, but then you're actually subtracting this, which is why it's really messy. So if you subtract each of those terms, you'd have a minus 2a squared, a minus 10a, a plus 1a, and a plus 5. Now if I combine all the like terms in the numerator, I have a negative 2a squared. 4a minus 10a would be negative 6, plus 1 would be negative 5a, I think. And a plus 13. Did anybody else get that disgusting answer? Not that bad on the quiz because it's not, I don't think you even have to FOIL them together, but if you do, I'm almost positive I picked a addition problem instead of a subtraction this problem so that I wasn't catching you on that crazy distribute the negative business, okay? What else? Can I skip this? This is just a whole lot of factoring and then reducing, right? Do you need to see this one where you multiply through by the common denominator? Anybody? Yeah? Okay. This one has a k times a k minus 4 as the denominator. So the least common denominator would have both a k and a k minus 4. So remember, this one, because it's an equation, we can just multiply all the way through by the common denominator, and it will get rid of some of the denominators. So if we multiply this by a k and a k minus 4, we multiply this term by a k and a k minus 4, and we multiply this by a k and a k minus 4. Here the k would divide out, and we'd end up with 3k minus 4. Here the k would divide out, and we'd end up with something we need to FOIL. And here the entire denominator would divide out, and we'd end up with plus 1, but we no longer have a denominator. Now, do you need me to keep going? It's in the answer key in Google Classroom, okay? You would have to FOIL this together, get it equal to 0, because it's going to have a k squared. I don't know if it has an extraneous solution. If you FOIL this together, and distribute over here, I don't know what's happening with my tablet today. If I subtract this 3K from the other side over here and add the 12, I get negative 10K, I think, plus 25, which actually factors K minus 5 and K minus 5. Yep, absolutely. So K would be 5, and that is okay. The only thing we can't have is a 0 or a 4 for the denominator. I don't know why my tablet's being wonky today. All right, so that covers that section. Haven't talked about this in a little while, so I feel like I should talk about these. Degree is the highest exponent, but you have to remember, kind of ignore all the adding and subtracting. You have a 2x squared, then this is an x minus 2 quantity cubed, which would result in an x cubed and a whole bunch of other garbage, but we don't care because we only care about the leading coefficient, and then back here there's another x. So what would that exponent power become? Two x to the 6, so the degree is 6. The leading coefficient is 2. We really only care that it's positive, but that means if it's degree 6 with a leading coefficient of 2, what does the graph look like? Even degree means the ends go the same way. Positive leading coefficient means both ends go up, okay? I have no idea what it's doing in the middle. But that means y approaches infinity, both on the left and on the right. And can you tell me the zeros? If I set 2x squared equal to 0, I just get x equals 0, right? But does that have a multiplicity? Because of that squared, be multiplicity 2. What? No, I'm just looking at each of these. Now if I look at the second one, x minus 2 equals 0. That's x equals 2. And that one is multiplicity 3. And then back here we had x plus 1. So we'd get negative 1, and that one's just multiplicity 1, which you really don't have to write. But remember, your multiplicities should add up to your degree. Does that help? Remember that check? Okay. Any questions about that? All right. Number of possible real zeros and number of possible turning points. This is degree. And this is degree minus 1. So what is the degree of this? 4, and degree minus 1 would be 3. Can anybody tell me how this would factor? If we have an x to the 4th minus 15x squared plus 44, because it has an x squared and an x to the 4th, and that's it for your x's, it factors x squared and x squared. Factors of 44 that make 15. I'm thinking 4 and 11. A minus and a minus. Is that fully factored? Which one factors further nicely? X squared minus 4 would factor x minus 2 and x plus 2 in any order. And then we have an x squared minus 11. But there's clearly a 0 at 2 and negative 2. But can we solve this? X squared minus 11 equals 0 would mean x squared equals 11. X would equal what? It's a real solution because it's not negative. Plus or minus the square root of 11. This exact is in caps because you cannot give me decimals, okay, guys? You have to write square root of 11 and negative square root of 11. Yeah, you could certainly say plus or minus, sorry. Any other questions on that section? Okay. This is the one I worry about. You're going to be given a picture. And it says on this particular one, it says the x's are counting by 1, but the y scale is unknown. So we don't know what this point up here is, okay? As a matter of fact, it wouldn't matter actually. It says that this point is 1/300. But where are the zeros? Well, first let's go through the questions. Even or odd degree? Even, because both ends are going the same way, right? You don't have to write that, I'm just reminding you. Okay, multiplicities. Okay, this is the x-axis. So it is crossing at 0. Please don't miss the one at 0, okay? It's crossing at 0. It's crossing at 1, 2, 3, 4, 5. Does that seem right? But what is it doing out here at 1, 2, 3, 4, negative 4? Okay, does everybody see it? It has a 0 at negative 4, but it does not change sign. It stays below the axis. That's what we call a bounce. So it has a multiplicity that's even. So we're going to say multiplicity 2 at negative 4. So it would be x plus 4 with a squared. Everybody okay where that came from? This is like a little baby parabola right here. So the root or the factor would be x plus 4 quantity squared. Okay, we can write x minus 0, or some of you can just put the x out front for the one at 0. And then there's one at 5. I think it actually asks on the quiz for you to list the zeros. So there was negative 4, 0, and 5, and then you would say multiplicity at negative 4, something like that. Okay. Anybody lost yet? It had a 0 at negative 4, 0, and 5. So we write x minus negative 4, which turns into plus 4, x minus 0, and x minus 5. All right, then we have to find the stretch. So we have y equals k times all this. What is the point they gave us? The extra point they gave us is 1/300. So we're going to put this in for x and this in for y. So we'd have 300 equals k times 1 plus 4 squared times 1 minus 0 times 1 minus 5. You can type all of this in your calculator at once because it is all multiplied. Whoops, sorry, I made that confusing. This would be 5 squared is 25 times 1 times negative 4. Is it like negative 100? Is everyone getting that? So what do we have to do? Do we add 100 to both sides? This was times, right? So we divide by negative 100. So I got k is negative 3. So final answer would be y equals negative 3. And I know that x minus 0, a lot of you would just put x. You can leave it x minus 0, I wouldn't care. and then it had an x plus 4 squared and an x minus 5. Now, you can type that into your graphing calculator, into the grapher, and see that it's bouncing and doing things. Because you don't know the scale, it would be pretty hard to make it look exactly like that, okay? If this is the 0.1300, the scale is probably like, 0 to 2000, or negative 100 to 2000, or negative 500 to 2000 or something on the y's. But you could certainly see that it was crossing and bouncing at those places. All right. Do we need to do synthetic division? If we did, remember it's negative 3. And then we have a 3x to the 4th, a 2x to the 3rd. Oops, we need a 0x squared in there, right? A negative 1x and a 65. I'm going to go kind of quickly, unless somebody needs me to explain. Oh, I got a remainder. I thought it wasn't going to give me a remainder, but it gets a gross remainder. Someone check me. Did anybody get that bad of a remainder? Negative 3, bring down the 3, 2, 0, negative 165. Did anybody already do this? Mary, did you do this already? Did you try this one? Did you have a, that's what you got? That disgustingness? Okay. So the quotient, guys, I don't know if it's this bad on the quiz, and it could be, but this gets, this is a constant. This gets an x, x squared, x cubed. So we have a 3x cubed minus 7x squared plus 21x minus 64 plus, how do we write that? It's 257 over x plus 3. Yeah, that's this is the divisor, so that's the denominator. All right, so that was disgusting. Is this x plus 5 a factor of the polynomial? Oh, maybe we were supposed to do 5. It says 3 here and 5 here. All right, well, I'm going to change this to x plus 3. I don't know what we're supposed to do. We can go back if we have time at the end and look if negative 5. But if this said x plus 3, I'm pretty sure they're supposed to be the same. Is this a factor? No, because there's a remainder, right? Explain how you know it isn't a factor because there's a remainder. Mary, did you try negative 5 with the x plus 5? You didn't notice that? You did, okay. Good job. We could try the negative 5 later and see if it works, but I'm just going to go with it. Okay. Long division. We need to do this one? Yes or no, guys? Antoine, can you tell me what the first one is? 2x squared times what would give me 4x to the 3rd? Good job. If I distribute the 2x through all 3 of those, I'd get a 4x to the 3rd plus 2x squared minus 2x. Then I'm subtracting all of that. Did I copy something wrong? Okay. We're subtracting all of that, or we can think of it as adding the opposite. So this is 0, this is a 10x squared. We add there and we get a 5x and bring down the minus 5. then I think we just need to multiply by plus 5. So we get 10x squared plus 5x minus 5. Guess what? When we subtract all that, or add the opposite, I'm thinking we get no remainder. So the quotient is just the 2x plus 5. All right, this is the misery. It's really not that bad. If it says 0 plus or minus 3 and negative 2i, why does it say dot, dot, dot? Because if negative 2i is a 0, there also has to be 2i. So how many zeros does this have? It has 5, right? Okay, it has to be, it says least degree, so it has to be at least degree 5. Now, it says with real coefficients in factored form. So I'm okay with putting an x or an x minus 0 for that one. And for 3 and negative 3, what am I going to write there? An x plus 3, okay, those two. But then when I go to write these two, I'd have an x plus 2i and an x minus 2i. Are those real coefficients? They're imaginary, so I can't write that. So I have to FOIL these two together. It's not as bad as it looks, right? X times x is x squared. X times negative 2i. Positive 2i times x. And then a minus 2i times 2i would be minus 4i squared. These middle terms should subtract, or yeah, sure. What is a minus 4i squared, guys? I squared is equivalent to, whoops, I have a negative there. Yes, I squared, you have to know, is negative 1. So this is x squared minus 4 times a negative 1, which would become x squared plus 4. And that will not factor. That's the whole reason we got what we did, right? Yes. That doesn't work. X plus 2 times x plus 2 would be x squared plus 4x plus 4. Yep. Yep. It does not factor. You have to leave it like that. Any questions? Just be glad I was kind, and it's like that on the quiz, okay? It's not one of those 3 plus I and 3 minus I, because remember how gross those were? Yeah, not even. All right, how do you write all the possible factors or rational zeros? Remember, it's all the factors of what over what? Constant over leading coefficient. So it's plus or minus the factors of 6 over 3. What are all the factors of 6, guys? Okay. And the factors of 3 for the denominator are 1 and 3. So when we rewrite that as a list of all possible, you'd have plus or minus 1 over 1 is 1, 2 over 1, 3 over 1, 6 over 1. But then you got to put them all over 3, right? What does that add to my list? 1/3, 2/3. But 3/3 is 1 and 6/3 is 2. So there's 1, 2, 3, 4, 5, 6, actually 12 numbers on my list, right? Because they could all be positive or negative. You don't have to list it that way. Just don't forget to put a plus or minus somewhere. All right, then you're to graph to confirm which of the above are zeros. And then you have to do successive synthetic divisions. All right, can anybody read me that polynomial? What did we start with? Okay. And we have a list of possible nice zeros. Looks to me like -3 or +3 and -2. What do you think? 3, -2. I can guess that that one in there is at 1/3. And it works, right? But I think actually if we use the two nice ones, we'll be okay. I already forgot what they were. Were they 3 and -? And then we did see that 1/3 worked. But I think as long as we do the two other ones first, we'll get that at the end. All right, what do we want to put in first? Anybody care? The 3, okay. And it was 3x to the third minus 4x squared minus 17x plus 6. Okay. 3 times 3 is 9. Add is 5. Multiply is 15. Add is -2. Multiply is -6. Add is 0. And it's got to be 0 or we did something wrong. Then we do -2. Now we can bring this down, multiply, add is -1, multiply is 2, and we get 0. Now how does that write as a factored polynomial, guys? Can we just leave this? What does that mean? Doesn't that mean 3x minus 1? Does that take care of the 1/3? That was our third 0. So we'd have a 3x minus 1, an x minus 3, and an x plus 2. Everybody okay? Now, I got to tell you, if you kept going and you did the 1/3, okay, if you had this, when you bring down the 3 and you multiply, you get a 3 left. That's because if you wrote this as x minus 1/3, x minus 3, and x plus 2, you'd have to put that 3 out front because the whole thing has to multiply back to this. Does everybody see what I'm talking about? It had to have a 3x cubed. Okay, so if you write x minus 1/3, make sure you keep that 3. All right, any questions on that? All right, then we have the good old third try. Oops, third try here on, I don't know what I just did. Third try on transformations. What would you do first on this one, guys? Yes. Anything inside the parenthesis is changing x values. And if you change like an x from a 3 over here to a -3 over here, that is a reflection across the y-axis. So this is a reflect over y. What is, this 3 is on the outside. It's like a 3 times f of x, which is 3 times the y values, which would do what? Vertical stretch by 3. Three times as tall, and then the -1 at the back would be a vertical shift. Yeah, and you can just say down 1. Okay, Remember, anything inside is the opposite of what it seems, but this is changing x values, so it's left or right. It's actually right 2. Then the negative out here is a negative on the y, which would flip it from something positive to negative, so it's going to reflect over x. And then up 8. What's this one, guys? This is the one we hate. That's changing x's, right? So it has to do with stretching or shrinking horizontally. Opposite of what it seems is a horizontal stretch by a factor of 2. The x's would multiply by 2, okay? And then have the up 3 on the end. Questions? Yes. Say that again. Yes. 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 This is a retake. Everybody has to retake it. All right. Now, I really want to not do quadratic again, but I felt like it went so badly last time that I'm pretty sure I put a quadratic on there again. Quadratic means an x squared, right, guys? If you have an x squared that's shifted right 5, it would be a plus 5 inside and a down 6. Yes, it would be a minus 5. Thank you. Don't listen to me. Okay, so right 5 and down 6 would be a negative 5 and a negative 6 as the vertex. Nope, a positive 5 and a negative 6. Holy smokes. Right 5 down 6 means over here at 5 negative 6 would be your h and k. But you can just write it like this. But we do need to figure out the stretch. Okay. 11 negative 18. This is an x. This is a y. Negative 18 equals a times 11 minus 5 squared minus 6. Anybody talk me through that? Please, please, please tell me you're going to remember to add the 6 over here. Yeah, and you can write that as 36a, but you are going to have to divide by 36. And that comes out negative 1/3. Anybody else get that? And again, you could go to your calculator and you could type that in. It was x minus 5 squared. Don't forget the squared. Don't forget the squared. Don't forget the squared, because it's not a quadratic without it. Okay, if I trace over to 5, it's in fact at 5 negative 6. And then what was the other point? 11? I'm going to have to look at the table. It's not in my window, but if I go down to 11 negative 18, okay? So you can check that you did it right. Oh, our very favorite. What two things are happening here? Because we can do it twice. This would reflect over what? Over the y. It would change the sign on all the x's. Can anybody tell me these ordered pairs real quick? This one is 2, 1. This one is 4, 3. Negative 3 something? Is this one -6, -4 maybe? Okay. So let's first reflect across the x. Where would -6, -4 go if you change the sign on the x? Over here it's 6, -4, right? And -3, 5, if you change the sign on the x, would go to +3, 5. 2, 1, if you change the sign on the x, would go to -2, 1. And 4, 3, if you change the sign on the x, would be at -4, 3. But what am I supposed to do to all of those in addition to that? That's a vertical stretch, right? So it's 2 times the y's. Yeah, I don't even know if we have room for that, do we? 2 times the y's. So this was down at -4. It's instead going to go down to -8. The x isn't changing, remember. This one was up at 5, so when you double it, it's going to go up to 10. Just off the top, maybe? This one was up 1. When you double it, it'd be up at 2. This one was up 3. When you double it, it would be up at 6. Did I double the right things? Yes, because we flipped it, right? I think it's right. Okay. What does this do? Yes, this is a horizontal shrink. So it takes all of the x's and does what? Yeah, cuts them in half. X's are divided by 2. So this one that was at -6, -4 is now at -6, I'm sorry, the x's, it's at -3, -4. Okay. When I did f of 2x, that one would go to there. When you cut the x in half here, you'd have -3 halves 5, which is like -1.5, 5. And then this one, when you cut the x in half, you'd have 1, 1. And this one, when you cut 4, 3, and you cut the x in half, you'd have 2, 3. But what's the last thing I'm also supposed to do? What is that -1 on the back doing? Moving it down 1. So each of those ordered pairs should shift down 1. I got to look at the quiz. I can't remember if you actually have to do one or if you have to just pick one. If you have to do it, I know I did not give you 2 things to do, okay? Only 1. No, yeah, it only asks you to do one thing. Let me grab my... Did we get through everything pretty much? I think we only skipped like one problem, didn't we, on the front? Okay, I can go back and do that one if you want me to, but this is quiz 7, right? Okay. Just so you're aware, The 2 retakes are at the end of the quiz, so don't get bogged down. Make sure you do those 2 retakes, okay? You do have to draw one, and you have to do a multiple choice one, okay? You have to draw one and do a multiple choice one. One of each, that's it. It's not like a matching with 6 different ones. It's like one, okay? All right, since I have time, if I go back and do, can you help me factor this? B minus 3 and B minus 4 for the top. The bottom would factor B minus 4 and B minus 4. Now, do we always flip this one over? Only if it says divide, right? If it doesn't say divide on the quiz, you don't flip over. This one says divide, so we flip it over. That B minus 4 comes to the top. And that one would be B plus 10 and B minus 8, I think, to give a positive 2 in the middle. All right, I think all the B minus 4s cancel, but otherwise nothing does, right? Did you need me to go back and finish number 1? Was it number 1 we didn't finish? Or did we finish? Oh, what was I thinking? Oh, we did finish this one, didn't we? It was 3, I was thinking, but we did finish it. All right, on the back side, there is some extra practice of particularly those ones where you have to deal with the rational expressions, okay? And there's a couple extra long division problems if you're worried about that, with the answers at the bottom. Any questions? I think I made a delta math. Did I make a